Welcome to this video. In this video, what I'm going to do is to provide the basics of the configuration inside the data center when you have a CLOS topology. What I'm going to do is to create the underlay. As a matter of fact, these are the tasks that we are going to do during the video series. I'm just going to configure OSPF, but ISIS, of course, is going to be very simple. So you can just do the configuration using that. And there are some problems that you might encounter when checking the underlay. So in this kind of a topology, we have multiple layers on top of each other. So we have the basic connectivity in physical layer, which is already done. And after that, we have the basic configuration and reachability of the network, which is going to be the underlay of the network. On top of that, we are going to configure VXLAN, and even better than that, VXLAN EVPN. And then the reachability in our network is going to be enhanced and to the most scalable possible situation. So I'm just going to do the basic configuration so that I can see. None of these devices have been configured before. All of them are in the default configuration. And we have S1 and S2. These are 9500 series. And L1 and L2, these are 9300 series. All of them have each 32 ports. And except these ports that you can see, none of the ports have been used anywhere. So the basic thing that I'm going to do is, first of all, I'm just going to decide what the password is going to be. And after that, I'm just going to save everything. And also, I need to make sure that the image, which is here, one of the images is going to be used for the boot up. And I'm just going to make sure that this is done. So this is just basic configuration of the Nexus switch itself, not the underlay, but that's going to be simple. So let's just go with this admin, and I'm just sending this configuration to all of these 4 devices. And the password for the beginning is nothing. So I just hit enter, and this is going to enter the privilege mode, but I cannot really save anything unless I have configured the password. So I'm just going to say for username admin, which is the network admin role, I'm going to configure a password of, let's say, Cisco 123 and hit enter. Of course, it should be in configuration mode. And then after that, the other thing which I'm going to do is to create an alias for write memory, because normally you should go with copy run start or copy run TFTP somewhere or something like that. But here I want to just type in WR, and after that, this is going to save everything. So I'm just going to say CLI alias. It's going to be name is going to be WR, and that's going to be for copy run start. So I hit enter. This is going to be the command to create the alias for me. And the other thing, like I said, is going to be a configuration of the image to boot up. Right now I have only one image, so that's not going to be a problem, but normally this should be there should be multiple images here, and one of them is going to be the most important one for you, which you are going to run. Most likely that's going to be the latest upgrade. So I'm just going to say boot NXOS, and that's going to be in boot flash. And in boot flash, this is the image. I hit enter. This is going to take some time, and I'm going to copy this to S2 and hit enter. And the other thing, this is going to be here. So I'm just going to copy this because the image is different. Boot NXOS, that's from boot flash, and that's the image. And the same thing goes to here. And like I said, this is going to take some time, and I'm going to just pause the video, and after that I'm just going to continue with saving the configuration and start configuring the underlay. It is almost done, and it's going to type in WR and save all the configuration. So you can see that I can use all the privilege mode commands in configuration mode. I don't have to type a do in front of them. Okay, let's go for the configuration. The first thing that I'm going to do is to type in show IP interface brief. You can see that right now there is no interface configured on none of these devices. The other thing is going to be show interface status. So this is going to be interesting because now you can see that on S1 and S2 that have 9500 images, all the interfaces are in routed mode, which is L3, and they are disabled, which means that this is shut down. Same thing on S2. But on L1 and L2, you can see that this is 9300. In this case, all the interfaces are no shots, and all of them are in L2 situation, which means that they are switch port interfaces. So they are connected and they are working just fine. So when you want to configure this interfaces on L1 and L2 for the fabric interfaces, I have to convert them to L3 interfaces using no switch port. And when you have this, when you configure OSPF or ISOS, what is happening here is you're going to use ECMP. All the links are going to be used. In case you go with L2, as a matter of fact, you have to disable some of the ports just to prevent loops in here, unless you go with some other type of configuration such as VPC. But in this case, of course, this is a fabric. So my fabric is going to be L3 completely. In a enterprise network, this is called a routed access configuration, routed access design. Same thing is going to go in CLOS Topology. Everything is going to be in route mode. So I'm just going to continue the configuration like this. So what I'm going to do here is to go to each one of the switches and configure the interfaces with the basic thing, which is going to be the medium and the type of the interface, which is going to be point-to-point in this case. And one of the reasons that I'm doing this is I'm going to use the loopback interface IP address for all the interfaces. So I don't really have to spend a lot of IP addresses in here. Management is going to be easier. Configuration is going to be easier. Also, all the interfaces can be unnumbered to the loopback. If I configure each one of these interfaces separately, this is possible. The routing table is going to grow a little bit. Also, what's going to happen is the management is going to be a little harder. You have to configure most of these interfaces using /31 or /30. So configuration is going to be a bit of a problem, and also management, like I said. But I'm just going to go with unnumbered interfaces. So let's go to S1, and I'm going to say host name is going to be S1, just to be clear in here. And I'm going to say interface E1 to is E1 1 to 2. And you can see that in this case, I don't really have to say interface range. And what I'm going to do is to say, first of all, no shot. And interfaces are going to no shot. And then I'm just going to say interface loopback 0. And IP address is going to be, let's say, 10.10.10.1 and /32. And you can use the slash notation in this case as well. So what I have here is I'm just going to go back to the interfaces, and then I'm just going to say, first of all, medium is going to be, you can see that the medium could be broadcast or P2P. In my case, I'm going to go with P2P. And the reason for that is you can see that all the interfaces have been connected point to point. I don't really have to go with broadcast. All the links have only 2 ends in this case. This is going to help, of course, to configure OSPF as well. In OSPF configuration, I don't really have to say the OSPF network is point-to-point because it is already point-to-point using this, let's say, type of a configuration, medium P2P. So I just do this, and I can now say IP unnumbered to loopback 0. The other thing that I'm going to do is to increase the MTU size in this case. This is where you need to be very careful because you have to do this everywhere. Otherwise, you're going to have some reachability problem. That's going to cause some problems with OSPF neighborship. So MTU normally does not cause inability to create adjacency, but the full adjacency, of course, is not going to happen in case of OSPF. So be very careful what you are doing. So I'm just going to say MTU. There's going to be 92.16, which is the maximum allowed in this case. And some of this, of course, later is going to be used for the overhead of VXLAN. Something like 50 bytes is going to be used for that. So right now, if I say show IP interfaces brief, it's going to show me the interfaces which have been unnumbered to loopback interface and also the loopback interface itself. So I'm just going to say show run interface E11 to 2, also loopback 0, and so normally not loopback 0, just say 1 and to 2. I'm just going to do the same thing on the other thing. So I'm just going to copy everything, go to S2 and paste it in here, and also I'm just going to say host name is going to be S2 in this case. Interface loopback 0 is going to have an IP address of 10.10.10.2/32. Hit enter and everything seems to be good. Same thing is going to happen on L1 and L2. So I'm just going to go to L1, host name is going to be L1, and what I'm going to do is to say interface E11 to 2, or let's just say interface loopback 0 first. IP address is going to be 10.10.10.3/32. And going back to these interfaces, I'm just going to say no switch ports. First of all, I want to make sure that these are in routed mode. And then MTU is going to be 9216. I don't need to say no shot because this is by default no shot. But I need to say medium is going to be P2P, which means that now I can say IP unnumbered to loopback 0. IP unnumbered to loopback 0. Okay, so here we are, and if I say show run interface E11 to 2, this is the configuration of these interfaces. It's very much similar to what we had in here, except the fact that this is by default shut down, but this is by default no shut. So I'm just going to copy this and go to L2 and do the same thing. So this is going to have a host name of L2. I'm just going to paste the configuration in here. Also, I need to say interface loopback 0. IP address is going to be 10.10.10.4/32. And here we are. Okay, so that's going to be the basic configuration of the interfaces themselves. So now what I'm going to do is to configure OSPF for all these switches. So let's first of all save all the configuration. Next, what I'm going to do is to say feature, and I'm just going to do this for every switch. So feature OSPF should be enabled. Then I'm just going to say router OSPF, whatever the process number is. You can just type 1. That's easy. And then what you need to do is you can just configure router ID. In my case, I have a loopback interface, so that's going to be taken for the router ID. But better to be deterministic. So you should go with router ID, and after that, type in the router ID in here. So that in this case, it's going to be 10.10.10.4. And for the others, of course, I'm going to configure. Let me just do this. Router ID is going to be 3. In S2, router ID is going to be 2. And in this case, of course, router ID is going to be 1. So this is deterministic because later we are going to add some more loopback interfaces here. So now that I have this, I'm just going to say interface loopback 0 on all of these. IP router OSPF 1. Area is going to be, let's say, 0. And you should make sure that all these devices are going to be in the same area. Otherwise, we are going to have some problem. We can have some scenarios in which some of the routers, some of the switches, as a matter of fact, specifically leaf switches, are in different areas. But in my case, of course, I don't really need to do this. So I hit enter, and all of these now are in area 0. And also, I'm going to say interface E11 to 2. Same command should be executed on all of these devices. Okay, now that I have done this, I'm just going to go for some verification to make sure that reachability is there. If I say show IP route, this is the first reachability configuration. Now you can see that right now, I don't see anything on S1, anything on S2. The only thing that I can see is my own routes, but after some time, I should really see that they are coming up. Show IP OSPF, let's say, neighbor, hit enter. Right now there is no neighbor, and I'm just going to say show CDP neighbor just to make sure that CDP is not enabled. So I'm just going to say CDP enable, hit enter, and after some time I should receive CDP messages in here. The other thing that I'm going to check verification is going to be show IP interface, show IP OSPF interface brief, hit enter. You can see that these interfaces have been here. The state is down for these interfaces E11 and E12, which means that, let me see what the problem might be. So if I just go to here, you can see that these interfaces are up on S1 and S2, but on L1 and L2, they are not up. So let me just see. Show run interface E11 to 2. So you can see that in this case, I have no switch port. I have the correct MTU configuration. I have the correct medium configured. Also, the unnumbered configuration, also the OSPF has been configured in here. If I just say no shot, of course, there have been no shot in here, but again, show, let's say, interface status is going to tell me that these two are connected, routed, which means that now they are in routed mode. One more time, if I say show CDP neighbor, hit enter, you can see that I can see S1 and S2 on these interfaces. Show IP OSPF interfaces brief. Now you can see that the neighborships have been configured and up and running. So if I say show IP OSPF neighbors, I can see 2 neighbors, and without even typing the IP OSPF network point to point, you can see that this is by default point to point. Why? Because the interface configuration says the medium is kind of point to point in this case. Same thing on L2, which means that now all the adjacencies have been done. So the other thing that I'm going to do is to say, are there any reachability or not? You can see that I can see 1, 2, 3, 4 on here, same on here, 1, 2, 3, 4 on here, and same on here. So I have reachability from every part of the network to other parts. That is going to be the basic configuration of the underlay. So the things that you need to be very careful about this is this. Your interfaces, their type is important. So if you do not configure medium P2P, you are using broadcast. If you do this on one side and on the other side there is no such configuration, then you are not going to see full adjacency in here, which means that you are not going to see a neighborship complete, and you will not see the routing here. Reachability ultimately is not going to happen. The other thing is going to be MTU. Like I said, MTU is not going to prevent the neighborship, but it is going to prevent the full adjacency, which means that the database completely is not going to converge. It's not going to be received from the other side. So be very careful about this situation. And again, it is going to cause not having enough reachability information in our network. And the other thing that I have written up here, wrong LSP flooding. This one is going to be important when you put your interfaces in different areas. If you do not configure this correctly, then you're not going to see all the LSAs from the other areas. Be very careful about that, specifically when you configure that with something like stop or NSSA or totally stop or totally NSSA configuration. Most likely you are not going to use it in this case. When you have a very big CLOS network, normally what you do is you go with database filtering. You don't really put in these devices in different areas. So database filtering is going to be better to make sure that flooding is not going to happen everywhere, and all the information have been secured in spines, but leaves are going to receive very basic connectivity, let's say information in your routing table. So this is going to be the basic connectivity of the network. In a later video, what I'm going to do is to add more sophisticated configuration to here.